So let's start finding the derivatives from first principles using that difference quotient with an easy first problem. If f of x equals 2x minus 3, find the slope of the tangent line at x equals 2. Call me crazy, I like to draw this first. I like to draw my graph. Y-intercept of -3, slope of up to over 1, up to over 1. So here is my graph. And the point here is what's happening when x equals 2. The function value when x equals 2 is 2 times 2 minus 3 is 1. This tells me my xy point is x is 2 and y is 1. So there it is. Our point is 2, 1. And we want to know the slope of the tangent line. Well, I'm going to use my difference quotient. F dash of x is equal to f of x plus h minus f of x divided by x plus h minus x. And I'm going to take the limit of this as h approaches 0, which gives us the limit as h approaches 0 of, well, I like to make a little chart over here. I know f of x is 2x minus 3. So I can substitute that for f of x there. F of x plus h is 2 times our input minus 3. And so what is our input? It's here. It's x plus h. So I'm going to make that substitution. If I now distribute that 2 out, I get 2x plus 2h minus 3. So when I'm asked for f of x plus h, I'm going to substitute in 2x plus 2h minus 3 minus, I'm going to substitute for f of x, 2x minus 3 over, well, this is always the same, x plus h minus x. Notice the limit as h approaches 0 of, if I now have to distribute out that -1, I get 2x plus 2h minus 3 minus 2x plus 3 all over x and minus x. If they've been good little x's, they go up to number heaven, and we're left with h there. If I substitute in 0, well, let's see, 2x cancels with -2x, and -3 cancels with 3 to give us the limit as h approaches 0 of this survived, 2h, and h survived. Now, because we have multiplication here, 2 times h over h, we can cancel that, and we're left with the limit as h approaches 0 of 2. Well, that's just a constant there, so there's nowhere for us to substitute in the h, and so our answer is 2. They're telling us a tangent line drawn to this graph will have a slope of 2. Well, at this point here, our slope is 2 over 1. Of course it is. With a line, our slope is constant. So we did all this work to prove, oh, the slope of this line is 2. We could have just looked at it and said, well, the slope of a tangent line here will be 2. And when I say a tangent line, if I draw a tangent line here, the tangent line will be the same as our line here.